Today we're going to be looking at circles and circumference. We've talked a lot about circles previous in the last couple of weeks up to this point now, and we've talked about circumference as well. So a lot of today's stuff will go pretty quickly. So here's our objective: to identify and use parts of a circle. Again, we're already pretty familiar with a lot of parts of a circle as is, and then solve some problems involving the circumference of a circle. So first, here's a couple definitions. A circle, all set of points in a plane that are given a given distance from a given point in that plane. Nothing too big there. The given point in that plane is the center. So the center point of this circle is A. We will also name circles off their centers. So I would name this right here circle A. Again, based off the center point. The radius, any segment joining the center of the circle to a point on the circle. So radius is segment AB, again going from the center, point at the center, to a point on the circle. B is on the circle, so that's why AB is a radius. A chord, we touched on this briefly with spheres earlier in the week. A chord is a segment whose endpoints lie on the circle. So FD, segment FD, again, both points F and D are on the circle, so that's why FD is a chord. A diameter is a chord that passes through the center point of a circle. So our diameter in this case is DB, going all the way through the center again. It is a chord because its endpoints are on the circle, but it actually goes through point A, which is the center, so therefore that makes segment DB a diameter. So circle A here, we're going to name some different things based off this circle. Center of the circle, easy enough. Center is A, point A. Two diameters there. One, again, diameters are chords endpoints on the circle that go through the center. So there's two of them in this case. One is segment FC. The other is segment DB. Four radii. The radii go from the center to a point on the circle, and there's segments. So there's four of them in this case. So AD, AF, AB, and AC. Those are all radii. 6 chords now. And chords have endpoints on the circle. So I'm going to start with DF, DF, segment DF, segment DC, segment DC. There's 4 of them. My last 2, again, I've already named, they're also the diameters. So FC is also, segment FC is also a chord, and segment DB is also a chord. So there's my six total chords. We've dealt with this a fair amount up to this point. So talking about the radius, that's going to be half the length of the diameter, and therefore the diameter is 2 times the radius. So looking at these 3 examples here. If I give you a radius of 7, I don't need the figure at all. I know the diameter is going to be twice that, so diameter is going to be 14. And the opposite, if the diameter is 32, and I'm looking for the radius, it's going to be half. The radius would be 16. Looking at this figure here for number 3, is CX congruent to segment EX? Here is CX right here. Here is EX right here. Again, point on the circle for E, point on the circle for C. They both end at X. Therefore, making them both, again, this is circle X, making them both radii. So I would say yes, they are. All radii, no matter where they are at, all radii of circles are congruent. Number 4, is segment AD congruent to segment BE? Here's segment AD, here's segment BE. And there are chords that go through the center, so they're making them both diameters. The same that all radii of circles are congruent, all diameters of circles are congruent. So this would be yes as well. Number 5, if CX, which is a radius, equals 9, then BE, a diameter, is going to be double that, 18. It does not matter that CX is not part of the diameter BE. We're still in the radius to diameter relationship. Therefore, it is going to be twice of 9, or 18. Then lastly, is dx greater than b, the length of dx greater than the length of be? Again, dx is a radius, be is a diameter, and that is no, because a radius will never be larger, the length of the radius will never be larger than the length of a diameter. We've talked about circumference. Circumference is the distance around a circle. Also, we've thought about that also as perimeter of a circle. So the ratio of the circumference of a circle to its diameter is pi. So that's where we get pi from. The circumference divided by the diameter of any circle. That's why we use pi in a lot of our answers. So just kind of a tidbit for you there. So a few examples now. I want to find the circumference of a circle with a radius of 2.3 miles. Again, for circumference, we have two separate formulas. Circumference is going to equal 2 times pi times the radius, or circumference is going to equal pi times the diameter. If the radius of a circle is 2.3, then the diameter is going to be double that, 4.6. So regardless of how I plug it in, circumference equals 2 times pi times 2.3, or circumference equals pi times 4.6. Regardless of how I plug it in, I'm going to get the circumference of this circle is going to be 4.6 pi miles. Number 2. This time I've given you the circumference of 116.5. I want to find the diameter. So another thing we've talked about in our 3D figures and things like that is we want to be exact. So I'm going to go back to the previous example real quick. This right here, this 4.6 pi miles, is the exact answer. If I want to be a rounded answer, I would simply take 4.6 times 3.14. And I multiplied 4.6 times 3.14 together. Again, this is my rounded answer. I would get 14. This is rounded, the squiggly lines, 14.4 miles. And we like to be exact most of the time. But looking at this second example, if the circumference is 116.5, I don't have pi in my answer here. I don't have pi in my answer. So again, my formula right here for diameter, circumference equals pi times the diameter. Because I don't have pi in my answer, I'm going to round and use 3.14 for this pi. So my circumference, 116.5, equals pi, 3.14, times the diameter. Go ahead and divide 3.14 from each side. And I get my diameter equals 37.1. Let's round that to the nearest tenth. So my diameter is 37.1. So again, if we don't have pi in our circumference, it's okay to round, and I'll clarify that before we have a test or quiz. This next one, number 3, says find the exact circumference. Again, if this is the square circumscribed, it's on the outside of the circle is inscribed on the square. So if it's 14 across, it's going to be 14 across anywhere I go. And that includes 14 across right through the middle. So therefore my diameter equals 14. If my diameter equals 14, again, circumference equals pi times diameter. Circumference equals 14 pi inches. Excuse me. And that again would be the exact answer because we have pi left in our answer. Number 4 here. This is a 10 centimeter chord. This is a 24 centimeter chord. To find the exact circumference, I need the diameter. We've been dealing with this for a while now. This is a right triangle. To find the missing side of a right triangle, we're going to use the Pythagorean theorem. So I'll call this my diameter. So my diameter squared, which is the hypotenuse, is going to equal the leg squared, 10 squared, plus the other leg squared, 24 squared. Diameter squared equals 100, plus 24 squared is 24 squared again is 576. 576 plus 100, I get the diameter squared equals 676. Take the square root of each side, I get the diameter equals 26. Again, if my diameter is 26, my circumference is going to be 26 times pi centimeters. And one more time, that is the exact answer there. One last one. This time we're given a chord of 8 radical 3 feet. But the triangle that is formed this time is if this is 30 degrees and this is 90 degrees, one of our favorites, a 30, sorry, I'll erase this, is a 30, 60, 90 right triangle. This 8 radical 3 ends up being the long side because it is across from the 60 degree angle. Therefore, let's go from the long side to the short side. And our rules real quick. Long leg equals the short leg times radical 3. So if I have my long leg, 8 radical 3 equals the short leg times radical 3. I look at the short leg by itself, so I'm going to divide by radical 3. I get my short leg, which is this chord, equals 8. If my short leg equals 8, now I'm going to go from the short leg to the hypotenuse. Hypotenuse equals the short leg times 2. So the hypotenuse in this case is also the diameter. Diameter equals the short leg 8 times 2. So my diameter is 16 feet. If my diameter is 16 feet, my circumference is going to be 16 pi feet. That wraps up today's lesson. Work on the assignment in class tomorrow, and I will be back in class on Monday.